everybody. Thank you for attending this section of the talk. My focus for the next 20 minutes is going to be on computational advertising. Precisely, I want to walk you through how this field has evolved from the simplistic assumptions we had to make in several years past to what it is today, where we are trying to come up with better modelizations of what the world of advertising really looks like. So what is computational advertising? Let's get that definition out of the way so the context is in place. So it refers to the task of showing a relevant ad to a user in an online setting using some sort of a programmatic approach, right? And of course, respecting users' privacy. The operative keyword here is relevant. I know a lot of us have been seeing a bunch of irrelevant ads these days, and as an industry, if that's where we are headed, obviously it's not going to make any money because users are not going to be interested in irrelevant ads. So the whole economics of that space depends upon showing relevant ads to users. Having said that definition, what was the very first digital ad that was ever created? Way back in 1994, that was the very first display ad that was online. It was for a tech magazine called Hotwired, and it was commissioned by AT&T, the first early adopter, I guess. And that was what the copy on the ad said. Have you ever clicked your mouse right here? Brand new experience. Nearly 1 in 2 people clicked on that particular ad because the world hadn't seen an ad in an online setting before. So much so that the folks who created the ad then realized that once a click happened, you needed to create some sort of a landing page experience, and that was a landing page experience that came about. So hopefully things have progressed way beyond the very first ad that happened, and these days we have a lot more sophisticated copies which try to be personalized to the user, a lot more relevant. You see display ads. You see ads in a search context. When you search for a specific item, you see product listing ads, sponsored search ads, ads in different sorts of media experiences when you're playing videos, as an example, even when you're shopping, be it in an app store or in an online store, even in your social feed, right? So why do we care about all of this advertising tech? Again, it comes down to a fundamental question of why do we care about advertising at all? It's the way for the producers of the goods to let the consumers know, hey, I have this brand new product, would you be interested in buying it? And users who are interested in these products would be interested in knowing about these sorts of experiences. And since time immemorial, this has been the way to monetize content, right? Be it the newspapers of the olden ages. I shouldn't say old, but it also exists today, whether it's TV or radio to the internet pages of today, right? Advertising is the mechanism that keeps this sort of free content flowing. Now, that being said, how did this whole ecosystem work previously? Continues to have 3 main players. There is a user who consumes content and products. There's a publisher who's publishing content that the user wants to consume. There is an advertiser who is selling something that the user hopefully wants to buy as well. In the previous days, there used to be not that many publishers. Not all of the producers of content were tech savvy, say, and there were not too many advertisers. So it relied a lot on one-on-one interactions. You would possibly talk to an account manager and have sorts of guaranteed ads shown on your site and so on and so forth. Fast forward to today, where this is a screen grab from the Internet Live Stats. We have 3 billion Internet users, right? And maybe close to 1 billion websites that are alive. Today, not everything gets visited. I'm sure it's only a tiny fraction which gets most of the traffic. But think about the scale of this problem. Every time one of those 3 billion users shows up on one of the possible billion sites, you want to see if you can show a relevant ad. Now, how would you scale? How do these advertisers reach out to all of these different publishers? And what if you're not one of these mega publishers of the world? How do you get in contact with the advertisers to say, hey, I have inventory that is good for you to monetize? So this is the complicated landscape that the ad tech space looks like today, which is difficult to parse, but there are several optimizations that can be done along the route, and I'll give you hopefully a cartoon reality. A lot of aggregation that happens on either side. You have things called supply-side platforms, which try to aggregate the inventory from many, many different publishers. So in some sense, think of them as user aggregations. And then you have the demand-side platforms, which you can think of as aggregating demand or asks from the advertisers to reach specific types of users. In between, you have many different models that can be used, of which the most popular one is what we call real-time bidding, which literally works like an auction mechanism in which you place a bid for a display request that you want to service. There are, of course, continues to be high-tech, high-touch mechanisms like direct relationships and so on and so forth, but a bulk of the inventory is going through the ad exchanges, right? Having said that, then, how has the space evolved with time in some of the more interesting components in the ad tech space? The first part that I want to highlight here is the second price auction mechanism. For those of you who are familiar with auction theory and the way ad display request works is assume that I'm on New York Times as a user, and now New York Times wants to show me an ad. Now, New York Times will first try to fill it with the direct relationships that it has. So it would say, hey, I promised Nike that I'll show Nike's ads to maybe so many users, so Nike gets the first call. And assuming that that's not the case, it's going to be auctioned off in what we call the ad exchange. Now, how does this auction mechanism work? In theory, you have different bidders who are going to say, hey, I want to show an ad in this particular spot. And let's say they are going to bid 3 different bid amounts. And as with any auction mechanism, the highest bidder, the one who's bidding $3 here, is going to win that particular spot, but he pays the price of the second highest bidder, which is $2. Auction theory clearly says that this is a good strategy, and it incentivizes the bidders to bid their true value. So it's easy for somebody participating in this mechanism to not try to game it too much. All you need to do is say, this is how much I value this particular ad slot, this is what I'm going to pay, and then the whole marketplace is in some sort of an equilibrium. Moving on, there are, these days, several sorts of interesting changes that are happening in this sort of a marketplace mechanism, mostly because the publishers feel that they need to have more control over the sorts of auction mechanisms that are being set. Sometimes they feel that their inventory is not priced at the point that they would like, and once they hand off their inventory into a supply-side platform, they sort of lose control over the auction mechanisms that might be put in place there. And truth be said, there are all these intermediary pieces that could possibly be eating off of the money that the publisher could be making. Given that there is a whole bunch of concern around what is going on in these auctions, there happens to be a trend towards trying to move more control towards the publishers. There are all these mechanisms like header bidding, which is getting to be a big deal these days, where the notion is that the publisher has more finer control about the auction mechanisms, what is the floor prices that they are going to set, and so on and so forth. Now, why is this interesting for us overall, for someone who is interested in doing machine learning for advertising? So imagine that I'm going to predict whether I want to place a bid on a particular display slot, right? I would have previously modeled this as an estimation of my value, how much money am I going to get, and I would have placed a proportional bid on that particular slot. But now that's not going to be the case anymore. With the advent of things like header bidding and moving away from second price to mostly first pricey auction mechanisms, I need to be able to bid the right amount to be able to win that auction as well. So there is a move away from not just modeling your true value, but also to be able to model whether you're going to be able to win that auction at all. And that mix of not being able to predict where you will be is a pretty interesting and a challenging problem, and how we modelize this is causing quite a good bit of research challenges to come up as well. So we talked about the auction mechanism itself, and I touched upon this a few minutes back, where you want to bid the expected value, and most of the machine learning literature focused on this very simplistic equation, where you're trying to model the probability of an interaction with an ad, assume that it is a click, or it could be a conversion, or it could be an add to basket, or any other sort of interaction you value, and what is the sale amount, or what is the revenue you're expecting to make from that sort of a click. Now, a majority of the published work focused on the prediction of this interaction value, mostly as a click-through rate estimation more than anything else. And there has been some work which tried to modelize it as a conversion rate estimation problem and so on and so forth. Why do we go after click-through rate? Why is this such an interesting problem? Think about the life of how a user clicks on an ad and then looks at a particular product and ends up buying something else, right? All of these different actions do not happen instantaneously. There is some amount of delay that happens, and also when you're trying to say, hey, a sale happened, is it because of this particular ad that the user clicked on? Were there other effects? So there are all these attribution questions which come into play, which are difficult to control the noise levels of, and consequently, just modelizing the click makes it an easier problem. That is not to say that is the right one to solve, but that's where most of the focus was, because you get this instantaneous feedback and you're able to modelize it quite well. Right? So a whole bunch of work was done on then estimating this click-through rate. Majority of it, keep in mind, these are all real-time bidding systems. We have less than 150 to 120 milliseconds from the time you get a display request to decide if you want to bid, what is the product you want to show, to actually show it on that particular page, right? So it needed to be models that could react that instantaneously, and so there was a preference towards more linear modelizations than anything else. So logistic regression happens to be one which gives you exactly the probability of interaction that you would like, not exactly, to some approximation. And that was where a majority of the research focused on. There was also quite a lot of constraints that came in because of the scale of the problem. Any significant ad tech player is fielding billions of display requests a day, right? And the amount of click-through rate, which is the label, you can think of it in that sense, is super sparse, right? So now how do we learn from huge data which has super sparse labels in which there is some amount of delay in getting the labels as well, plus the fact that the feature space is also gigantic. There was a lot of work done in how to modelize this better, so quite a bit of thinking went into techniques like hashing, which try to reduce the feature space, trying to cope with mechanisms like having the model go out of date pretty frequently, so you wanted to keep updating the model on a regular basis, but you don't want to start from scratch as often, so there are mechanisms like warm start, but you want to not warm start from an overfitted model, so early stopping and so on and so forth, which tried to keep the pace of eking out however much value we could from the logistic regression space. There is also a parallel line of work which tried to come up with cleverer and cleverer features, if you will, and perhaps that's where it's headed, at least with respect to modelizing the interactions. Of course, you have to have a deep learning model, right, whenever there is some feature work that needs to be done. So more recent work these days are trying to focus on coming up with deep and cross networks, which try to make the feature engineering part a little less human-driven and more just driven by the data. But then an interesting question to ask is, I said, hey, you were talking about wanting to have linear models because you don't have that much time to serve. What about deep models, right? How do they work in a production setting? Well, they don't exactly. So most of the effort seems to be in using these sorts of, deep models to come up with features. And there is another layer which is closer to production, but still continues to maintain the simplicity, so you can maintain these sorts of SLA constraints. So one pointed to a work that came out of Microsoft Research, which tries to use a layer of embedding set of layers to convert the huge multi-million dimensional space into a more denser representation, on top of which you have your regular decision trees, which tries to make the prediction. Okay. Another assumption that we had, that the industry had made overall, is that there was an independence in the click behavior. So assume I showed up on New York Times. Now this is a display request, so I make a bid. Now, as a user, you would expect that I'm going to show up on New York Times again and again and again, right? So there was a tendency to ignore this sort of a return behavior of the user, the fact that I would be participating in the auction over and over again. Again, the assumption had to be made to make the modelization easier. But these days, we are moving away from having to treat this as an independent approach to saying, hey, let me try to modelize the entire space in some some sense, right? Classical way of thinking about it, you could think of reinforcement learning as a mechanism in which you want to frame this problem. So you have some sort of a user state, and the user state is not just the user's context, but also what is the budget that is left, how much have you paced your campaign, how much money do you have left, and so on and so forth. So you can think of a state as encompassing all of these different factors. Then you have an action that you're going to take, which is the bid amount that you're going to place on that request. And then there is a reward that you're going to observe, and the reward could be hopefully a click or a conversion or a sale. Now, the fact that this reward has been observed is going to affect the next state that the user is in. In some sense, you have exhausted some amount of the budget that the advertiser has set aside for you. The user has also been influenced by the ad, so that is going to affect the next action that you're going to take. So there is one nice piece of work that we did in Criteo research where we found that the moment you get your first click, it's not necessary to bid up on that particular user again. You might as well wait for some time because there is a pretty high probability that you're going to get that attribution to that click. So call out to that particular piece of work in AdKDD of this year if you're interested. But given the sorts of data that we are able to observe and also the machinery that is in our disposal, we are able to move away from saying, hey, every display request is an independent statistical sample to saying there are these sorts of dependencies that we want to modelize, and with better techniques such as reinforcement learning and so on and so forth. Last piece that I want to touch upon is the recommendation problem, and how does this fit into the whole space. So I had a display request on New York Times. I placed a particular bid request, and say I won that bid request, right? So now I need to show an ad to the user for whom I made a display request. Now, how do I construct this ad? I need to figure out what is the right relevant product to show to this particular user. Now, how do we frame this problem? You can think of it as a classical recommendation system problem. Now, what are the signals that go into it? I'm just going to walk into some simpler examples. Say this was a user who clicked on some sort of an orange shoe. So one candidate selection mechanism could have been to say, hey, yeah, this was something that the user expressed interest in, so we want to show him the same shoe. But hopefully, everybody's smarter than that, than showing the same shoe over and over again. That doesn't necessarily work. But you also get a whole bunch of different signals. You also get something like a collaborative filtering signal, which says, here are the other users who were on the same site, and here are the other products that they viewed. Now, this enables us to come up with things like what is the most popular item on that particular site, what was viewed. You could also do something like a collaborative filtering technique, and so on and so forth. And finally, a purchase happens, and here is some sort of a sale that happens, right? So you can think of coming up with this as a modelization of a simple recommendation system problem. Simple because it's classical, not because the scale is simple. We are still talking about a catalog which is in billions. We are talking about users who are also in the billions. So imagine trying to frame this as a problem that, again, is able to return a recommendation in less than 100 milliseconds. So the scale is what makes it tricky. This sort of an approach did not take into account the sequence of user behavior, right? So there is some context in what the user has done in the past, which might inform what he's going to do in the future. So yes, we did look at the fact that that particular orange shoe was clicked on by the user, but there is this entire timeline that we could possibly exploit in making a better recommendation. So you can think of sequences of user item interactions that are being made available to us, right? The fact that this user clicked on the sequence of products over a period of time, what is the next product that he or she is going to interact with? Not only do we have the sequence of these interactions, we also have the time intervals between these different interactions. The fact that the last interaction was just a minute ago or it was a few days ago, what is the context in which we had these sorts of interactions? Was it during a day? Was it during the weekend? And so on and so forth. So there is a rich set of feature values that are being made available, which we can possibly exploit in the recommendation system as well. So that's pretty much what we did. To formalize this problem then, so you have a feature vector which consists of the user timeline and the context in which those timelines occurred. Now, given that, you want to predict the probability of the next event in the timeline, given everything that you've observed in the past, including the context that you have observed in the past and the current context. Now, one framework which can help you frame this sort of a problem is the popular recurrent neural nets, and that was what was used in this piece of research. So you can think of having an input vector which consists of both the event as well as the user timeline. You're going to embed it because, of course, you cannot operate in the raw space as is. And then you're going to want to modelize what is the next action that you're going to take, given the current context, as well as the previous state that the user was in. To make it work, we had to borrow some techniques on how you want to integrate in, or not integrate in, bring in this sort of a context matrix, and using it as a multiplicative factor enabled us to make more progress than if you were to concatenate the whole thing. I would refer you to our paper in Rexis if you're interested in following this along. Now, again, I wanted to very quickly by giving you 4 possible examples. One in bidding, one in how we are modelizing the problem of click-through rate, one in how we are modelizing recommendation, and of course the change in the auction theory, and the scale at which the whole ad tech space is changing to say that the field is moving ahead. We are leveraging more and more of at least stronger machine learning modelizations. I would not say it's AI at present. Anyways, AI is a grossly misused term, but that's another topic. But it's at least stronger machine learning modelizations which are truer to reality than what has been done in the past. So that pretty much brings me to an end, and I don't know what's going on with that slide. If you have further questions, please feel free to tweet us, and we'd be happy to answer you at Criteo Research. So thank you.
Thank you, Suju.